All right, so we're going to talk about what makes two triangles. So first of all, we're in pre-calculus, which means that we're going to possibly give you sides that don't make a triangle, sides that make one triangle, sides that make two triangles. Okay? We want you to be able to handle all the things that we throw at you. So when you look at this first one, we decided yesterday that it was not possible to get a triangle from angle A 52 degrees, side A 6.5, and side B 10, right? A was just too short, okay? How long did A have to be in order to make a triangle? 7.9, okay? So it's not working right now, and let's see what happens in the calculator when we try this out. So if we set up sine of A over side A, as it stands now, equals sine of B over side B, what's going to happen when we solve this guy? Well, sine of B is currently being divided by 10. Opposite division is multiplication. When I multiply on the right by 10, I have to multiply on the left by 10. Break out our graphing calculator, make sure it's in degrees. We take 10 times the sine of 52, and we close our parentheses, we divide by 6.5, and I get that the sine of B is 1.212324, blah, 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 blah. What's going to happen when we try to get that angle back? We're going to get an error. Why are we going to get an error? You don't have an actual triangle. And if I try to take an inverse sine of 1 point something, calculator is going to say error in domain. Error, problem, right? We have an issue here because sine can never be bigger than 1 or smaller than -1. Make sense? So if we try to throw an impossible triangle at you, the calculator is going to help you out and say, hey, dummy, that's not going to work. There's no triangle here. Make sense? All right, so that's the first piece. Okay, so now, if it's one triangle, it's one triangle. We're going to get it through the law of sines, right? But if it's two triangles, we want to have a heads up to be able to figure out why we're getting two triangles. So let's think about what's happening here. How long did side A have to be in order to get a triangle? 7.9. Okay, so when A is less than that height, we don't get a triangle. But when A is equal to the height, we get a right triangle. And if A is bigger than the height, we're going to get two triangles, right? Remember that from yesterday? So let's make it slightly bigger. Let's make it slightly bigger than 7.9. Let's make it 8.2. Okay? So we're going to get two triangles now. If I get to here, I get one triangle, and then I go a little further, and I get a second triangle. So that's our ambiguous case. Only happens when we've got two sides and an angle, right? Not the side angle side, but two sides and the non-included angle. Okay? So now we know we have two triangles. Okay, why was that? Well, A is currently smaller than B, right? But it is also, actually, it's bigger than H, isn't it? Okay, so A is smaller than B, and A is bigger than H, and that's when we get two triangles. Does that make sense to everyone? Okay, so how can we write that in one nice streamlined thing? One nice streamlined inequality? Who's got to be the smallest? H less than A less than B. If our height's less than side A, which is opposite of angle, and that is less than B, then we get two triangles. Now, yesterday we had a way of deciding how to get H, right? How do we find H in this triangle? And that would move this over here so the number's not confusing you as to who's who. Colors help, but not always, okay? How do we figure out what H is? Exactly. The sine of angle A is H over the hypotenuse, B, H over 10. And so if I want the H by itself, B times the sine of angle A is going to be my height. So this guy is going to be B times the sine of angle A. Well, that's got a kind of a nice pattern going with it. B times the sine of A less than A less than B. So far, so good? What if I didn't give you angle A? What if I gave you angle B, side B, and side C? How could I translate that to say it? Now instead of B sine of A, it's going to be C sine of B less than B less than C. Everybody cool with that? Notice that the A's are closer together, they're toward the middle, the B's are on the outside, B's are close to the middle, C's are on the outside. What if I gave you an angle C and a side C and a side A? Then we would write it as exactly. So there's 6 different combinations that we can write it down, right? But hopefully you see the pattern there, or you can figure out what H is using signs, sine SOHCAHTOA. So in that little bubble that you had yesterday, write a few of those down or at the top of your paper from your assignment. This is your test to see if we've got 2 triangles, okay? If A sine C is less than C is less than A, 2 triangles. If C sine B is less than B is less than C, 2 triangles. If C sine A is less than A is less than C, 2 triangles. We got to find them both. So far, so good? Okay. Now, what happens when A is bigger than B? Get rid of some of this mess. A is bigger than B, we get a triangle, don't we? Everybody see it? But then when we come over here, it's too long, right? It's not going to make another triangle. So we're just going to get 1 triangle. Okay? So we don't have to worry about a 2 triangle situation. 2 angles on a side, don't have to worry about it. It's just the angle side side or side side angle that we have the ambiguous case. And it only happens when we've got these 3 things going on, or these 6 things going on. Depends on which way it is. Okay? A sine C less than A, 2 triangles, so you got to find them both. Feeling good? Okay, now, on your sheet, we had it back here with A is 8.2. So let's find those 2 triangles one more time. Let's change A to 8.2. Walk through that process. Bless you. And we'll run through the test to make sure we know how to do it. Find out that it's 2 triangles, and then we'll work our way through. Okay? So, test. How do we know for sure that this is going to be 2 triangles? Well, A is 8.2. 8.2 times the sine of 52, right? Our A has to be less than 8.2 less than 10. We're using this guy. that make sense? Actually, not that one. Yeah, that one. Okay, everybody with me?
It should be 10.
10. No, sorry. Let me try it again. Erase. We're saying B sine A, 10 sine 52, less than A, less than B. Right? Okay? These two, definitely, we can look at it and see it. So far, so good. Now, when we take 10 times the sine of 52, we get what? 7.8. 7.8 less than 8.2 less than 7? Or less than 10? Absolutely. So we know we have two triangles. Okay? That's our algebraic test, so we don't have to draw the picture. Okay, so we know there's two triangles. We're going to solve it like normal, but then we're going to make sure we leave some room for our second triangle. Okay? We just have to make some space. First triangle. We say sine of 52 over 8.2 equals sine of angle B over 10. We're going to take 10 times the sine of 52 and divide it by 8.2. So 10 sine 52, close parentheses, divided by 8.2 gives us the sine of B, 0.96. That's better. We can get a sine of B that's 0.96. We do a second sine, second answer, and we find out that angle B is 73.94, depending on how many decimals we want. All right, so there's one of our answers. That's the first answer. We're going to put a star beside it so we remember to go back to that star. So far, so good? Okay, now we know angle A, we know side B, we know side A. Now we know angle B. Let's go find angle C. Angle C is going to be 180 minus the 73.94 minus 52. Three angles of a triangle have to add up to 180 degrees. 54.06. Okay? Now we got to go find side C, and we're going to say the sine of 54.06 over C equals the sine of 52 over 8.2. So when we cross multiply here, C times the sine of 52 equals 8.2 times the sine of 54.06. So we'll divide by the sine of 52 to find that our side C. So 8.2 sine of 54.06, close parentheses, divided by sine 52, gives us an 8.42, little c, 8.42. We're done with one triangle. Law of sines. As if we were oblivious to it, didn't know it in the past. Okay, just like we did before. Now, we know that there's a second triangle. So we've got to find the second triangle. Okay, so we remember from yesterday, hopefully, that when we have that second triangle, okay, this guy we figured out was a 73.94 degree angle, right? And when we want to get our other triangle, that over here a little bit. Oops, I didn't mean to do that. This guy, move it. Okay. So now when we move this guy, we're going to get this second triangle over here, right? And because of that isosceles triangle that we had over here a moment ago, this is 8.2, this side's 8.2, isosceles triangle is 73.94 degree angle, 73.94 degree angle. All you have to do when you want to find your new angle B is find its supplement. The first guy you found, take 180 minus it. Okay, so 180 minus 73.94. gets us our new angle B. 106.06. Okay? That and the 52 are two of our angles. Subtract that from 180, and we get our new angle C. 21.94 of our second triangle. And now we use the law of sines once and we're done. We can find angle C. Sorry, side C. So let's do the law of sines one more time. Sine of, we can start with our original 52 over 8.2 equals the sine of our new angle C, 21.94, over our new side C. And we try to get the C by itself, so we're taking the sine of 52. Wow, I didn't put my sign up there very well, did I? C times the sine of 52 is 8.2 times the sine of 21.94, dividing by the sine of 52, we're going to get 8.2 times the sine of 21.94, close parentheses, divided by sine 52, and we get 3.88. So our new side C is 3.88. And we found our two triangles. Not too bad, right? All right, let's see how we did. So if we show those angles, 3.8, right? I'm not quite at the exact spot. 3.8, 3.9, something like that. I'm only rounding to one decimal place here. Does that make sense to everyone? Now, you can decide. I'm not going to draw the triangle. It doesn't help me. I want to use the algebraic test, right? You can decide, I'm a visual person. I would like to sketch the triangles and use a protractor and a ruler, and it's going to help me be able to see it, understand where it's coming from, right? You can also say, you know what, Mrs. Bender, I'm feeling kind of lazy. Anytime I see an angle, side-side or side-side angle situation, I'm going to assume that there's two triangles. And I'm going to go ahead and find the first one. And then that first angle that I find, I'm going to find a supplement, add it to the original, and if I'm over 180, I know, guess what? It wasn't supposed to have two triangles. Does that make sense to everyone? So you have three ways to do it. I don't care what works best in your brain. Figure out what helps you learn this material and use that method. Protractors and rulers will be available. If you need help, let me know. Okay? Assignments, the next page of your packet, front and back. Sketch them if it helps. If it doesn't help, don't sketch them. It doesn't matter to me. You're not going to hurt my feelings. Okay? All right.
Can I use the restroom?
Absolutely.